Let's start chapter number 6, energy stores and transfers. You can see here there are different types of energy: mechanical energy, thermal energy, nuclear energy, chemical energy, electromagnetic energy, sonic energy, gravitational energy, kinetic energy, potential energy, and ionization energy. So, there are different forms of energy: potential energy and kinetic energy. We have chemical energy, stored mechanical energy, gravitational potential energy, nuclear energy. Similarly, in kinetic energy, we have radiant energy, motion energy, thermal energy, electrical energy, and sound energy. What is potential energy? Gravitational potential energy is the energy associated with an object's height. Very important point. The formula for potential energy PE is given by mass times gravitational constant times height. Okay. The gravitational constant is 9.8 meter per second square. For example, if a sheep weighing 47 kg is raised to a height of 6.3 meters, we can calculate the increase in potential energy. The formula is PE equals to mass times gravity times height, mgh. Here the mass is 47 kg, height is 6.3 meters, and g is a constant value which is 9.8 meter per second. So an object total potential energy, which is measured in joules, joules is the unit, will be 2961 joules. As an object descends, its potential energy converts into kinetic energy. The increase in kinetic energy equals the decrease in potential energy. What is kinetic energy? Kinetic energy refers to the energy associated with motion. So if the energy is associated with height, it is potential energy, and if it is associated with motion, it is kinetic energy. Any object that is in motion possesses kinetic energy. The formula for kinetic energy is half times mass times velocity square. Alternatively, you can write Ke equals to half times mass times velocity because it's velocity square. For example, if a car with a mass of 2450 kg is moving with a speed of 38 meter per second, its kinetic energy will be calculated by multiplying half times mass times velocity square as per its formula, and you will get the energy in joules. Since kinetic energy is influenced by both mass and speed, heavier object moving at a higher velocity will have greater kinetic energy. What are the types of energy? Let's examine more complex computation that includes gravitation, potential energy, and kinetic energy. For example, a moldy tomato weighing 140 grams is dropped from a height of 1.7 meters. Calculate the velocity at which it strikes the ground. So the potential energy lost as calculated by mgh, m is given, g is given, h is given, and you can calculate PE. G sometimes it's written as 9.8, sometimes written as 10. Both are okay, both are fine. Therefore, kinetic energy gained is equals to the potential energy lost, which is 2.38 joules. Now to calculate the kinetic energy, we have a formula half mv square. We can write 2.38 equals to half times 0.14 times velocity that we need to calculate. By simplifying, you can note that the velocity of this object is 5.38 meter per second. Let's talk about energy transfer. Energy is passed on from cells to various sources. Any source that provides electricity is also delivering energy. The cells, batteries, generators, and similar devices transfer energy to the current in the wire, which subsequently conveys it to the components or devices within the circuit. You can see here power supply provides the energy. There is kinetic energy, light energy, heat energy, and also the sound energy. We can utilize a Sankey diagram to illustrate the energy transfer. What is a Sankey diagram? It simplifies the visualization of how much input energy is effectively utilized versus how much is lost. The arrow's thickness indicates the amount of energy they represent. So, for example, we have this amount of energy input, and now it is converted into useful sound energy, some of it is converted into light energy, and then some energy, heat energy, is also wasted. Example in television. During a roller coaster ride, energy transformation occurs as the coaster moves along the track. So, there are more examples here. Converting gravitational potential energy to kinetic energy and vice versa. At any point, the total energy is the sum of kinetic energy and gravitational potential energy. In the absence of any resistive force such as friction and such things, the total energy remains unchanged. The phenomena is referred to as conversion of energy principle. Energy is neither created nor can be destroyed, it is merely converted from one form to another. Typically, some energy is expended overcoming friction and air resistance, and it results in heat loss as well. Let's talk about efficiency now. A fossil fuel power plant typically operate at an efficiency of around 33%. So, what does this indicate? This indicates that one third of the thermal energy generated from the fuel is converted into electrical energy. The remaining two-thirds of energy is lost, simply heating power plant and area around it. So you see, our input of energy is 1000 joules, and we are only getting 372 joules. Remaining lost in transmission, lost in power station, lost heat loss in the environment. We can calculate efficiency. We have a formula: useful energy output divided by total energy input times 100%. So here in this case we have the output 372, input was 1000 times 100 to 37.2% is our overall efficiency. With this we have finished our this chapter. See